Welcome back, class. I know we're getting out of school early today to celebrate the holiday, so today's lesson will be a short one. The next big part of our algebra unit is learning how to solve quadratic equations. So today we're going to talk about what it means to solve a quadratic equation.
Excuse me, Mr. Caldwell, but what holiday is it? On my home planet, we don't have a holiday today.
Today's the Great Monstrumpus, Codette.
What is the Great Monstrumpus?
The Great Monstrumpus is a day of universal respect and understanding among monsters.
Ha! More like a fake holiday for monsters who want to hold hands and sing songs and pretend we are all friends who never eat anybody's brains or suck anybody's blood.
And also, there's candy. Mr. Caldwell, can you let us out a couple minutes early so we can be first in line for the funnel cake?
Ooh, I love funnel cake.
Bones, I'm happy to let everyone out a few minutes early, but only if we finish today's lesson first. It's a quick one, so let's all get our thinking caps on. Here we go. We're about to start an important part of our unit on quadratic equations. We've learned what quadratic equations are, how to write them, and what their parabolas look like, so we're finally ready to start learning how to solve them. But hold on for a second. What does it actually mean to solve a quadratic equation? After all, the graph of a quadratic equation is a parabola, right? And a parabola is made of millions of tiny dots strung together, where each dot is one solution to the equation. So doesn't solving a quadratic equation just mean drawing its parabola? And isn't that what we've already been doing in this class? Well, yes and no. There's an important part of solving quadratic equations that we haven't focused on yet. Let me show you what it is. Here are two equations. They're almost the same, except that the first one starts with y, and the second one starts with 0. The rest is identical. Notice that the part on the right side of these equations, the x squared plus 3x plus 2, that's really the quadratic part because of the x squared. So these are both quadratic equations, even though one starts with y and one starts with 0. When it comes to solving these equations, though, that small difference changes our answer a lot. The first equation is like all the other quadratic equations we've studied so far. Whatever number we plug in for x, we get a different answer for y. And since there are no limits on what numbers we can put in for x, this equation has tons of solutions. I mean millions and billions, a whole parabola full of solutions. Think about it. If x equals 1, then y equals 6, which means that the point 1, 6 is a solution. If x equals 2, then y equals 12, which means the point 2, 12 is another solution. We could keep plugging in x values and get millions of different points as solutions. But our second equation doesn't start with a y. It starts with a 0. And we haven't seen an equation like this in our lessons so far, so let's pay attention to how it's different. Why will it change our equation to have a 0 here instead of a y? Well, this equation is pretty much the same as our first equation, except that this one is asking us for just a couple of solutions out of those millions of solutions in the parabola. In other words, this equation is saying, whoa, that parabola is a lot of solutions. Can you just show me the ones where you get y equals 0? And when we do that, almost all of the points on our parabola will not work anymore. For instance, the points we just calculated, 1, 6, and 2, 12, do not work in this second equation. The only points that do still work are the ones where y is 0, and we can see that those points are here and here, our x-intercepts. In this case, they're -1 and -2, because they're the only numbers we plugged in for x that gave us y equals 0. This makes a huge difference in our math problem when we compare what these two equations just asked us to do. The first equation had millions of points, millions of solutions. We couldn't possibly figure them all out. But our second equation has just 2 answers, which means we can figure them out. So those answers are what we usually mean when we talk about solving a quadratic equation. We mean figuring out just these 0 points, these places where we can plug in a number for x that gives us a y answer of 0. And so, starting now, we're going to begin seeing a lot of our quadratic equations written like this. Instead of y equals something, we're going to see 0 equals something. It's just a way of saying we're not interested in millions of answers anymore. We're not interested in a whole parabola anymore. We're only interested in these 0 points. If we do see an equation that still has the old y equals format, then it might ask you to figure out just the zeros, or roots, which means the same thing we just talked about. It means ignore the rest of this parabola. Just tell me the points where the parabola crosses the x-axis. Solve this equation for y equals 0. To make sure you understand, let's try a couple of examples. V9, if I give you this equation, and I ask you for its solutions, what am I asking you for? Do I want you to give me a whole parabola full of millions of solutions?
Negative. This equation begins with 0 equals, not y equals, so the only solutions that are allowed are x values that give us y equals 0. So the number of solutions here will be very small. A parabola contains trillions of solutions. This equation will not have a parabola for its solution.
Good, V9. Now, Wendigo, what if I kept the same equation and just changed the beginning to y equals? If I ask you to solve this equation, will we have a very small number of solutions or a very large number of solutions?
Teacher, in this equation, any number we plug in for x will work. There is no restriction that says y must equal 0, so there will be infinite solutions to this equation, and the solution to this equation will therefore be a parabola.
That's right, Wendigo. The parabola you mentioned looks like this. Which brings me to one last question. Suppose we keep this equation, but this time I ask you to tell me only its zeros, or roots as we sometimes call them. Will the solution still be our whole parabola here, like it was last time? Or, when we ask for just the zeros or roots, will the solution be something different?
The zeros, or roots, are only the points where the parabola touches the x-axis. In other words, the x-intercepts, the points where y equals 0. So the solution will not be our whole parabola. It'll just be a small number of points from our parabola.
Excellent, Ruby. And now that you all see what it means to solve for the zeros of a quadratic equation, you might be thinking to yourself, hey, this isn't so bad. We've seen something like this before. And you're right. Remember, one of the ways we learned to write a quadratic equation was called factored or intercept form. In factored or intercept form, we would take a quadratic equation that looks like this in standard form and rewrite it like this, where we have one factor times another factor. Each factor is x plus or minus a number, like x minus 3 or x minus 4 here. And these factors show us where the x-intercepts of the parabola are. All we have to do is figure out what number we can plug into each factor to give us 0, and that number will be an x-intercept. In this case, if we plug in 3 to the first factor, we get 0, or if we plug in 4 to the second factor, we get 0. So those are our x-intercepts. Our parabola touches the x-axis at those 2 points, positive 3 and positive 4. Intercept form made it pretty easy to solve this quadratic equation in exactly the way we said we need to solve it for our upcoming lessons, by finding those 0 points, those x-intercepts. Think about how useful that is. If someone asks us to find the solutions, the zeros, of a quadratic equation that's already in factored or intercept form, then we're in luck. All we have to do is figure out what numbers we need to plug into each factor to give us 0 inside its parentheses, and those points are our answers. Factored or intercept form is so useful when we have to figure out zeros or solutions that we're even going to learn in our upcoming lessons how to take quadratics that aren't written in factored or intercept form and convert them into that form. Because if we start with a quadratic equation in standard form, then knowing how to turn it into factored or intercept form is going to be a huge step toward figuring out its solutions, because it's much easier to figure out the x-intercepts when the equation is in intercept form. What I'm trying to tell you is, a lot of what we're about to do in our next few lessons is similar to what we've already done. We've already learned about solving quadratic equations because we've learned about parabolas, and that's what parabolas are. We've also already learned about solving for the zeros or roots of quadratic equations because we've learned about the x-intercepts of our parabolas, which is what the zeros or roots are. And we've already learned one of the most important ways to solve for those x-intercepts, because we've already learned how to write a quadratic equation in factored or intercept form, which was invented for exactly that reason, to help us figure out the x-intercepts. So does everyone understand? I want to make sure nobody feels confused or intimidated by the small difference between these two ways of writing quadratic equations, because we're going to see them a lot in our upcoming lessons.
I understand, Mr. Caldwell.
I understand too, even though I am getting a little hungry for funnel cake.
Good work today, class. From now on, let's just pay careful attention to what it means to solve a quadratic equation. Sometimes it means drawing an entire parabola, but sometimes we're just talking about finding the x-intercepts of that parabola, also known as the zeros or roots. In other words, the numbers we can plug in for x that will give us y equals 0. That's what it often means to solve a quadratic equation. That's all for today, everybody. Now go out and have a great monstrumpus.